Good evening. Here we are with section 7.3. We're going to look at how to simplify radical expressions. So this will build off of what we've been already working on. I've got our handy little table here, the exponentials at our disposal because it will be helpful, but we will be working sort of the other way. So we're going to be like taking the square root of 25 is 5. So these numbers over here in the exponential part will be helpful for us as we work through these. So let's just get started. So what we're going to do is we'll look at how to apply the product rule, which means we're going to be multiplying things with radicals, and the quotient rule, which means we're dividing things with radicals. Okay, those two things is really what we're doing. So I don't know, I like to call the radical a house. And so the properties that radicals have, remember they are an exponent, a rational exponent. So this is really a 1/2 power on a square root. So the way they work is if they're in separate houses, they can be brought into the same house when we multiply. This doesn't work with addition or subtraction, but multiplication or division, we kind of have some fluidity in dealing with them. So we could either do it this way where they're separate, and then we could take each square root. Square root of 4 is 2, square root of 25 is 5, 2 times 5 is 10. Or if you would like, you can combine them into one square root, one house, multiply them, and then say, well, square root of 100 is just 10, and get to that answer right away. So it just depends on which facts. You know, this one used 4, square root of 4 is 2, square root of 25 is 5, or we could have used square root of 100 is 10. So whichever one you kind of want to use. So just in general, when we have radicals and it has the same index, notice this is to the end. So remember, these have an index of 2 if you wanted to. We don't write it, but it's there. So as long as the index is the same, it's the same kind of house, we can go in there. Now, if the indexes are different, we can't do this. This is like a different house. They just won't fit. Okay, house rules are different and everything. So we'll make use of this. And again, it's all about trying to reduce or simplify an expression down and maybe be able to write it without a radical or with part not in the radical and part in the radical. So here's an example. We could say, oh, I know 36 is 6 times 6, so this is 6. Square root of 4 is 2, so this is 12. Or you could do it the way they did it, I think. There we go. 36 times 4 is 144, and then look up 144 is 12. Here's one of the things you're going to see me do. I like to work with smaller numbers because once they get to these bigger numbers, I'm less likely to know those facts. It's just me. Okay, I know the smaller ones. I could see this was 6, and I could see this was 2, and so it was a lot easier to deal with it this way. You can go this route, but you might not have recognized that 144 is a square root, that the square root of 144 is 12. Of course, we do have that table we could use, right? We just, where did it go? I closed it. So let's get it open again. There it is. Here we go. Sorry about that. There it is. Try not to close it again. So you can come down here. So that's okay. I mean, however you want to do it. So how about this one? Now this is a third root, so that means you need a power of 3. And again, we can multiply these out. Let me just show you what happens. You get 216. Now I'm definitely going to need to look that up in the table. Okay, it's a third root. Let's see, here's 216, that's 6. Okay, we could do that. Or if we go here, I have a better chance. I remember, okay, 8 is 2 times 2 times 2. So this is going to become negative 2. A cube root of 27 is 3 times 3 is 9 times 3 more is 27. So that one I could figure out. This is just going to be 3. Negative 2 times 3 gives me negative 6. That's the way I would have worked it. This way, I would definitely need to go look it up in the table. So, again, up to you. This one, a fourth root. Now, that's something times itself 4 times. There is no, 4 is not on the fourth root table, right? So we're over in this fourth root. We start with 16. I could reduce 16, but I can't reduce the 4. I don't know why this does this. There you go. It's a little bit better. But then there's another one over here. So what I might do, though, is take this one, go with this one, right? We can be creative here. You can, I'll show you. They just go straight ahead and multiply it all out and get a big one. But this is 4 times 4 is 16. Here's another 16. And we just looked up that a 16 is 2 times 2 times 2 times 2. So this becomes 1/2 times 1/2. 1/2 times 1/2 is going to be 1/4. Now, again, what they did is they went ahead and multiplied it all together, got 256, perfectly fine. Then you got to go look up the 256 here, and that's 4. I went down here with the smaller. 2 times 2 is 4. Multiple ways to do this. You decide what works best for you. And sometimes one way will work better, sometimes the other. But yeah, and again, the way the 1, fourth root of 1 is 1. 1 is a great number to work with. It's when we're dealing with radicals. The radical, any radical of 1 is still 1, because 1 times 1 times 1 times 1 is still 1. So that's that one. Okay, now remember with these, this is square roots. So again, we could break them down as we go, or sometimes we're going to find it's better to just go ahead and multiply out. So I'll do what I think they're going to just multiply it out, but square root of x squared, remember, 2 factors equals 1 on the outside. 2 factors on the inside equals 1 on the outside. So this is x squared. That's going to become just x. There's x to the 4th, so x, we've got 4. Let me see. I got to make sure you guys can see. We've got 4. 2 become 1. These 2 become 1. So it looks like x squared comes out. So the final answer should be x to the 3rd, right? Because x to the 1 times, so we add the exponents. Now, what they're going to do is put them in the same house, multiply them, and when they multiply them, they add the exponents, and then they take half of 6. So this, what we're really doing is we're dividing by this index. This invisible index is 2. 6 divided by 2 is 3. Okay, so let's see how we can do that with this one. 5 times 10 is going to give us 50. And notice I'm going to multiply because there's not 3 that could come out here. There's not 3 here. But if I put them in the same house, 5a times 10a, I get 50a to the 3rd. Okay. This 3, I can take 3 divided by 3, so that's going to give me a to the 1st power. Now 50, see, think of the factors. This has a 5 and a 2, and that's a 5, so there's no, it's just all the 50's got to stay inside. There is no cube root of 50, can't be reduced. So that's going to be our final answer. And again, they do it slightly, well, they did the same thing. They put it all in the house, they do this, and then 3 divided by 3 is 1. So 1 can come out, a to the 1st comes out, and then 50 is still left inside the radical. Same thing's going to happen here. So we'll just go ahead and let them walk through. But what we do is once they're in the house, we can do some canceling. Y divided by y, right? So what they're doing is canceling out. Well, maybe they do it over here. I would have done it here. But notice that canceled, that canceled. You get fourth root of 21. I would just go ahead and do it here. Say, well, so 3 times 7, I would have went right there. Saved a step. It's up to you. Okay. And how do we know that the fourth root of 21? Well, we come look at our table of fourth roots. There's 16, there's 81. 21's not going to be in there. 21, 7 times 3. So a lot of this is we are breaking down numbers into their factors. That's what this is really about, factoring. Okay. So when we simplify radicals, we determine the largest perfect nth power factor of the radicand. What does that mean? What we do is, so like with a square root, you're looking for a perfect square. A cube root, you're looking for the perfect cube, the largest one that you can take out. Use the product rule to factor out and simplify this perfect nth power. So it'll make more sense when we do it, okay? Just believe me. So I'll show you. So 500, what they're saying is, okay, what's the biggest perfect square in there? Okay, so we look for 500. There's 512, but that doesn't work. Oh, wait, we're cubes. Here we are. Okay, no, we go to 400. This doesn't go any bigger, and I'll tell you, yeah, 500 isn't one of the perfect squares, but which of these numbers will divide into 500? Oh, there's 100. 100 goes into 500. So I could write this. Well, they went ahead. They got it on me. So they rewrote it as 100 times 5, broke it into 2, and then square root of 100 is 10. So we're able to get the largest square root out. Okay. Down here, we're looking for cube roots, right? 40. 40 is 8 times 5. And if I remember correctly, 8 is a cube of 2. 2 times 2 times 2. So we're going to be able to take 8 out. The 8 is 2 to the third. So what comes out, a cube root of 8 is 2. And I think we'll have this cube root of 5 left. Watch what they do. So yes, they break it down. 8 times 5 is 40, and we get it simplified. The 2 came out because cube root of 8 equals 2. Nothing we can do with the 5. It's left in the house, so it's just got to be there. Okay, so this is a simplified expression. 72, it's a little harder. I know that, what is 8 times 9? And it's a square root. I know 9 is a perfect square, but 8 is not. But 8 is 2 times 4. So I could break it down like that. Looks like a 2 is going to get left in there. 9, so a 3 can come out, a 2 can come out. I'd say, see, look at this. I'd say I get a 2 times 3 on the outside, square root of 2 on the inside. So I'm going to say 6 square root of 2. That's how I would break it down. Let's see what they do. So yeah, 36. 36 times 2 is 72. Okay, that's good. And they're following the rule of look for the biggest one. But I tell you, I didn't see it. I tell you, bigger numbers. So what I did see 72 as 8 times 9. And I just wanted to give you the alternate way. We can get to the same answer as long as we break it down into factors, right? I knew 72 was 8 times 9. 9 is a perfect square. I can get that one. That's the 3. 8 wasn't, but I could break it down to 2 times 4, and 4 is it. So break it down, bring it out. Again, this was rather easy for me. This would have taken extra time, and I'm not sure I would have really spotted that because I don't remember what my 36 times tables is. I just don't. Should know that 36 times 2 is 72, but you know, this came to mind first, so let's just do it. Okay, so multiple ways, whatever works for you. Again, this one you're going to see pretty straightforward. 49 is a square root of 7, and then we're going to take half of this, so 4 divided by 2. So they break it into two houses. First one is 7, the second one is 4 divided by 2 is x squared. So they all come out of the house. Here's a square root. 75 is not a perfect, but I could see maybe a 25. 3 times 25 is in there, and 25 is 5 times the square root of 25 is 5. So I can see probably a 5 coming out, a 3 being left inside. 5 is not an even, but 4 is. So 4 divided by 2 is 2, and that would leave 1 inside, right? And they're going to break it down for us. So that's my mental thinking, which I want to kind of walk you through. And then here they go. They actually break it down. Yeah, 25 times 3 is 75. Y to the fifth, they broke it down as y to the fourth and y to the first. That would give us the y to the fifth. But this one will be, everything will be able to come outside, right? 25y to the fourth, breaking it to two different houses. Okay, and this is 5y squared, which we had, and 3y still inside the radical. That's how that's going to simplify. Over here, what I'm going to think is 9 is 3 times 3. And so when I bring them together, I've got 3 3's, 3 factors, 3 3's being multiplied. So I know there's a 3 that can come out of there. I've got 1 here, and I got 2 there, so I'll have 3 A's inside the house, so 1 can come out. Right? That's what that 3 says. It's kind of like the door guard. If you got 3 of them, it lets 1 of them out. Okay, so that's the way I think of it. And W's only got 1, and there's nothing over here. So I'm going to say that my answer here is going to be correct. They will walk you through all the steps. They put it together like this. They multiply it. But again, as we get larger, the cube root of 27, I should recognize that is 3, but I could also deal with the factors here a little bit easier, breaking it down. That 9 was 3 times 3, and I could see I'd have 3 factors of 3. I might not remember it with a 27. Okay. Of course, I got my table. I could pull that out and do that. And then they get the A3. And so they do this, and then they do that. So we got the same thing together. So you'll find the way that works best for you. I know this is a topic that shows up in college algebra as well, so that's why I want to make sure we spend a little bit of time on these and get these concepts down. You won't have to work too many problems on them, but it's good to have it down. Okay. So now they're going, this one I think is a little overkill. In fact, I didn't give you any of these type of problems. So let's just say, hey, forget it. But I'm going to click through. They break it down to exponents, and then what you're going to do is add these exponents. Okay, looks like fun. Not really, but I'm not going to have you do any of those. We generally don't see those. If we're going to do something with these, it's not important to go that route. So, but just recognize that you can add exponents. Okay, so that's exposed you. That's good enough. I don't give you any problems like that, so we're not going to work with this. Now we do get a few of these. This is with the quotient rule part. So this is equivalent to what we were doing with the multiplication part. So if they're in one house, we can break them up into 2. If they're in 2 houses, we can put them into 1. So whichever way we want to do it, 4 over 9 can be reduced down to 2/3. Notice how square root of 4 is 2, square root of 9 is 3. So you could do it that route, or you could do it all under one house. But basically, this is equivalent to the product rule we had. If you've got them in one house, you can split them into 2. And if you've got them in 2 that are being divided, again, the important part is that the index is the same on all of these. We can put them into one house and then simplify. Okay, so 7 over 27, simplify the radical expression. Well, a cube root of 7 we can't really do, so what you're going to see is we'll get a cube root of 7 in the top. Cube root of 27 is 3. Okay, and again, they walk us through and say, okay, let's split the houses. cube root of 27, that's 3, 3, 3. So we get the 3 coming out. Okay. This one, a fifth root. Again, x is just to a single power up here, but 32 is 2 times 2 times 2 times 2 times 2. So this is actually a fifth root of 32 is going to be 2. I would expect to see fifth root of x over 2. Okay, and that's considered simplified. Okay. When we're in separate houses, again, we could bring them together, and then so that allows you to take 90 divided by 10 first. 90 divided by 10 is 9. Square root of 9 is 3. You can do a lot of this mentally. Of course, I always like to show your work, but that's sometimes overrated. Sometimes being able to think your way through it will work as well. Okay, so we go there. Here, those y's are just going to cancel, right? And then we've got a square root of x to the fourth, 4 divided by 2. I can jump to this and I can just say that's going to be x squared. And they will do the same thing, maybe. There we go. Put it in one house. We'll cancel out the y's. So now we just got the square root of x to the fourth. Remember, this square root has an index of 2, so 4 divided by 2 is x squared, just what we had. Fifth roots, same type of thing. We're going to break this up, and fifth root of 32 is 2. X to the fourth, there's not 5 in there, so that's got to stay inside that fifth root, right? X to the fourth. But y to the fifth, there's 5, so 1 comes out. They had the ticket, the price is 5 y's to get 1 out. And they break it down, and you'll see this part here is 2, the bottom part is just y, and we have the same answer. Okay. This one, again, simplifying, sometimes this is a little bit over the top, but what we're able to do is bring them into the same house. X minus 1, x plus 1. We can multiply this. Remember, this is a difference of squares, so you get x squared, x plus 1, x minus 1, that's going to be 0, and then negative 1 times positive 1. So it simplifies that. Now be careful, you cannot take the square root of x squared by itself because we've got a subtraction going on, not a multiplication. We're done here. This is all we can do. But they call that simplified. Okay, and again, a lot of what we do with algebra is to break things down and put them back together in different ways, and sometimes we can reduce things and make them look prettier. Okay, here we go again. They're in the same roots, so we're going to be able to factor this. Now think back to our factoring, right? There's 6, so we're going to have, I mean, they'll do it for us, but 6 is 2 times 3 or 1 times 6. Now notice we're adding them. If you added 1 and 6, you get 7, not 5. So it must be 2 times 3 because 2 plus 3 is 5. They're both positive because that's what we have here. So again, you could try it, multiply it out, you get back to where we started. Notice here's an x squared, x plus 2. So those guys are going to cancel, and we're just going to have cube root of x plus 3. So they do that, they factor it, these guys cancel out, there we are. Okay, so bringing back together everything we've worked through. And that's going to be it for 7.3. I've got 10 problems in Pearson for you to work through. Let me know if you have any questions. You can send me an email is one of the best ways to get a hold of me. You can put it into the discussion forums in Canvas, but again, it's probably easier. And if you let me know which ones you're struggling with, I can make a mini video of those, or we can check in during class time. I'm here quite a bit during the day. Well, I don't leave home. I'm, just like we're supposed to, right? We're staying home. So let me know if you need anything, and we can, we've got Zoom meeting. I learned a little bit about WebEx, which is the sort of the supported version that they're using now. So we can meet and um, work through some problems together, make sure that you're understanding. Okay, so we'll end this session, and then I'll do one on 7.4, and we'll be set for class. Thanks.